All right, this is the lecture on different types of maps. We're going to start with cartography. Cartography is the science of map making. And whenever map makers make maps, they have to make some decisions. No matter what they do, there's always going to be a certain amount of distortion taking a three-dimensional object and putting it on a flat piece of paper. And so map makers have to take into consideration what they want to show and what they want to show accurately and what they're okay with not showing accurately. And then they also have to take into consideration what kind of scale and projection do they want to use. Do they want to zoom in? Do they want to zoom out? Maps really serve two purposes. They find locations, help us to find locations, and help us to depict human activities across space. Now, if you're trying to do your Google Slides and try to do an example for cartography, just stay put there, hold on for a little bit, because we're going to go into a lot of different maps, and you can use any of them in terms of cartography. Okay, so again, the question is, how do I put this three-dimensional object onto a flat piece of paper? It's always going to get distorted somehow. So the map maker has to choose, do they want to distort the size of the land masses, the shape of them, or do they just want to eliminate large portions of the Earth to maintain accurate size and shape? And we'll kind of take a look at all those. So this one is the Mercator projection. And the Mercator projection distorts the size of some of the land masses. And in particular, I want you to take a look at Greenland and Africa. Now, Greenland has benefited from a Mercator projection. Greenland really should be 1/11 the size of Africa. In other words, you should be able to take 11 Greenlands and fit them into Africa. And if you take a look at Antarctica, Antarctica looks like it's as large as the entire world. It is certainly not that big. And so what we see with the Mercator projection is that while there's some good from it that we're going to talk about, there's also some bad as well. So let's start with the good. Okay, the good of the Mercator projection is that it's very easy to locate places. So if you're doing latitude and longitude, like maybe you did in middle school, I'm sure that your teacher probably used a Mercator projection because all the lines are nice and straight and they're at right angles, and it makes it really easy to locate places on the Earth. Now, it preserves the shape of the continents fairly well. We'll see that it doesn't do that, though, with the size. Okay, so this the main distortion on this is it distorts the land masses, and in particular, you're going to see that the land masses are distorted pretty badly at the poles. And so Greenland and Antarctica especially, they're distorted to make them look a lot larger than they actually are. Okay. Now, we'll talk about this later, and we'll talk about what ethnocentric is. But in a Mercator, especially for a Mercator in America, it's kind of laid out in an ethnocentric manner. What I mean by that is that it's laid out in a way that we view it and we view the world. And so when you look at a Mercator projection, if I go back here, the first thing we probably see is North America. The way that we are taught to read anything is from top to bottom and kind of left to right. And so it would make sense that as we read a book, we would read a poster the same way. And so the first thing we look at is North America. And so it seems like that's the most important thing that should be on a map. And that can be somewhat dangerous. We sort of get brainwashed as if that's the way the world actually looks. We really could look at the world this way. There is no top or bottom to the Earth. There's really no top or bottom in space. We are told the world looks a certain way, and we get used to looking at it that way. I know that's kind of messes us up, but that Mercator projection gets us looking that way. And so really, again, there really is no top or bottom out in space because there is no top or bottom. Here's an interesting way to look at the world. Here's the Chinese world map. You can see there that we're pushed way off to the right, and now you can see that for the Chinese map, they're smack dab in the center. Okay, the Peters projection. So this is just a different way of looking at the world map. And if you kind of look at Greenland now, you can see that Greenland probably has a better chance of fitting 11 of them in. The Peters projection, though, has its distortions too. Whenever you take a three-dimensional object, you're going to get some sort of distortion. Okay, the positive. The positive of the Peters projection is that the middle latitudes where most of the people on Earth live, those are relatively accurate in both size and shape for the most part. So 30 to 60 degrees north latitude and 30 to 60 degrees south latitude. So if you take a band through like North America and Europe and Asia, the places where probably about 4 to 5 billion of the 7 billion people live, that is pretty accurate. And that's what Peters wanted. When Peters made this map, the middle latitudes, he knew that's where most of the people lived, and he wanted that to be the most accurate part of his map. But the negative is that the polar region now, Antarctica, you can't really see, and Greenland is almost gone as well. The polar regions have been kind of squished or crunched, and the equatorial regions are elongated. They've been kind of stretched out. And so in this, the shapes of the continents are a little skewed up, and the size of them are okay. All right, on to the Robinson projection. Now, the Robinson projection can best be described as kind of the best of all worlds. It's like the pound for pound, probably the most accurate map. Even though it's not 100% accurate, it's pretty good. And so that's why a lot of map makers choose to use it. So the good of it is the general shape and size of the landmass is fairly accurate. But the bad, and when you see this in just a second, you'll understand, the bad is that it's not completely user-friendly. The line's curved. Now, the line's curved to try to make the land masses and the size and the shape of them accurate. But when you do that, then you lose the user-friendliness. And it is still somewhat distorted if you take a look at Antarctica. So here's a good example of a Robinson. You've probably seen a Robinson before, but you can see that in this particular Robinson, the lines especially, as you look at the meridians, the up and down, the north and south running lines, they are curved to mimic the shape of the Earth. And, it's pretty accurate in terms of size and shape, but then again, it's not as user-friendly as, say, a Mercator. Okay, and then the last one that we're going to talk about is the goods projection. The goods projection is, extremely accurate in terms of the land masses that are portrayed. So both the size and the shape across the world, really good. It really is probably the best projection in terms of accuracy. But the problem is, and you're going to see this in just a second, it is really a wacky projection, and it's not very user-friendly at all. This is what's called an interrupted map, and so they have cut out portions of the oceans. But again, the map maker didn't really care about that because they are concerned with the land masses. They wanted the land masses to be accurate. So, the oceans are what get cut out, and therefore it's interrupted. So here's what it looks like. I know, kind of interesting. But again, there you see, the size and shapes of the landmass is pretty good. And then you can see the interruption. It kind of looks like somebody took a globe and cut it up and kind of tried to flatten it out and put it on a piece of paper. Okay. That is it for the types of map projections. Next lecture, we will look at the different types of human geography maps that we'll look at this year.